So in our next example, we have a different kind of distribution. We have a normal distribution. Hopefully you remember normal distributions from earlier in the year. They make kind of these bell curve shapes. And this normal distribution, we were told, has a mean of 64 and a standard deviation of 2.7. So we know that here and here, which would be one standard deviation away, should be 66.7, and this would be 61.3. And we should probably, hopefully, remember that in between one negative standard deviation and one positive, that's 68% of the data right there. Okay, so just keeping in mind all those different things. So here's what they want. They want to know the probability of finding a person that would be bigger than 68 or less than 70. So we would want to figure out where these values kind of fall in this chart over there and try to figure out this area right here. So the first thing I'm going to figure out is this 68. If we take our 68 and subtract it from 64 and divide it by our standard deviation, that's going to give me a z-score. So 1.48. So it's about 1.48 away from the center. And then let's find the other one. We're going to find our other z-score. So doing the same thing. 70 minus 64 over 2.7. So this one's probably a little bit further away. So this is 2.2 repeating. So if you remember, we'd be looking at this curve, and we're trying to figure out, we just standardized all these scores, so given this is my mean, which would be at 0, we're trying to find this space in here. Well, if we look at the z-table, we can find that at 2.2, and if we go to repeating, which would be the third column, so this one, about 99% of the data is going to fall there. So if we kind of think about our chart from 2.2, which is that spot right there, 98 or 99% of the data, if we round up, will fall in between there. So that would be 99%. Now if we find our other one, which would be at 1.48, which would be about 93% of the data, because 1.4 and then we go over to 8. Or it'd probably be one more over, yeah. So 93% of the data would fall in between here and if you want to figure out this part in here, well, if we took this entire amount and subtracted it from this entire amount, it should be this open space here. So 6% of the data would fall in between that space. So this would be 6%. So it's going to be a lot of the same stuff that we did before with normal distributions. We're just giving some of these probabilities and setting them in more of a refined space.